This video is about more complex inverse functions and graphs of inverse functions. Alright, well last time we learned that inverse functions can be kind of weird. So let's talk about them in both an algebraic sense and a graphing sense. I'm going to try to keep this as short as I can because this is really an easy thing to go into very deeply. So the first thing I want to say is that if I have inverse functions, if I plug it back into the thing that it's the inverse of, I should get x. And this negative, this f with a -1, that's the correct symbol for the inverse of a function. So it is true this way. It's also true if I take the inverse of the function. Hope I can write my x's properly. That those two conditions should be true. And if those two conditions are true, then two functions are inverses of each other. Okay, so Mr. Clark, how do I find an inverse? There are basically three easy steps, and I'm going to write them off to the side. Step number one is going to be replace the f of x with y. It could be f of x, g of x, whatever you want. You're going to replace it with y. Step number two, we're going to swap x and y. So everything will stay the same. We're just going to change the location of x and y. We're going to flip-flop them. And then our third step is going to be to solve for y. If we do this and it's correct, we can double check using this rule up here and verify that we've got an inverse function. So let's get started. Hopefully I've got enough room for this. Let's look at A. All the way down to A. All right, so I'm going to start by finding the inverse of this. So step one is rewrite f of x as y. So y equals 4x minus 14. Step one done. Step two, I'm going to swap x and y. So this becomes x equals 4y minus 14. Bear with me. From here, what I'm going to do is now solve it for y. So I'm going to start by adding 14 to both sides. And I get x plus 14 equals 4y. Then I will divide everything by 4. And I will get that the inverse function is going to be x plus 14 over 4. Is that the right answer? I don't know, and we're going to find out. So the first thing that I'm going to solve for, I'm going to solve the second one that I wrote up there, which is the inverse function being input. So f inverse into f of x. And this is going to be, let's see, we're going to take our inverse function, the x plus 14, and we're going to plug the 4x minus 14 into this x here. So let's go ahead and do that. So let's see. 4 times x plus 14 over 4 minus 14. All right, so we're going to take that. We're going to cancel the 4's. We get x plus 14 minus 14, and that equals x, which is a good sign. So this is actually, oh, I did it backwards. This should be, look at me not writing my stuff down right. This should be f of the inverse of x. Okay, so let's now do it the other way. And that would be to take our fraction and put the other thing in there. So that would be 4x minus 14 plus 14 over 4. Looks gross. I know fraction, it's okay. We don't have anything going on here, so it's just going to be straight addition. So that simplifies to 4x. See, negative minus 14 plus 14 is gone. So 4x over 4. The 4's cancel, and I just get x. So it gives me x one way. It gives me x the other way. These are definitely inverses. And I've proven it. We're going to do the same thing with g of x. It's going to take probably some squishing on my part. Let's see if I can get this to work. So let's do a squiggly boop here. Okay, so the first thing we're going to do is find the inverse. So I'm going to swap the g of x to a y. So y equals 1 half x plus 3. I'm going to flip-flop the x and the y. X equals 1 half y plus 3. I'm going to go ahead, I'm going to move the 3 over first. So I get x minus 3 equals 1 half y. To clear that fraction, I'm just going to multiply everything by 2. Okay, this is not a squared, that's a 2. I promise, I was just jamming it in there. So we get 2x minus 6 equals y. So our inverse, what was that function? G, before I put f of x. So our inverse function here, the inverse of g of x, should be 2x minus 6. So we're gonna do both variations and see what we can find. So let's do the first one first. And I'll do a woobly wooble so we can stay nice and organized. I'm sorry, it should be G. Used to f of x's. G of inverse of x. Okay, so what we're going to do, we want to take our inverse and plug it into our original. So we have our original was 1 half x. So this would be 1 half. Our x was 2x minus 6. And then plus 3. Okay, so 1 half times 2 is just x. 1 half times 6 will be 3. And then minus 3 plus 3 is 0. And we get an x. It's looking good so far. Let's see if the other one does the same thing. That'll be the inverse, and we're plugging in g of x. So the inverse was 2 times, and our first one was 1 half x plus 3. And then we had a minus 6 on here. Okay, 2 times 1 half is an x. 2 times 3 is 6, and then minus 6. 6 minus 6 is 0, and we end up with x. So we got an x the one way, we got an x the other way. Therefore, these two are inverses. It's not too bad. It does take up a lot of space. That's okay. If you stay organized, these really aren't too bad. You just have to keep track of what you're putting where. If it's being weird, you can color code your g of x and your inverse so that you know what's going where if you want to. That's not what I do, but I've seen people do that successfully. So, like I said, it takes up a lot of space to prove an inverse, but it's really not very hard work. So let's go ahead and look at the graph here. Let me scroll down here on my tablet. Okay, so we're going to be using the function f of x equals 3x minus 2. Should be pretty easy. So 3 times negative 2 is negative 6. Negative 6 minus 2 is negative 8. And I'll write that. I'll be a good teacher here. So this would be 3 of 0 minus 2. That should be minus 2. 3 of 3 minus 2, that should be 9, 8, 7. And that should be 12, 11, 10. So I'm going to go ahead and plot that. And I guess I'll do it with this kind of burgundy color. So negative 2, negative 8 should be here. 0, -2, 3, 7, and 4, 10. And let me see if I get a straight edge. I can hopefully make a straight-ish line. Okay. Done and done. The next part, we're going to do the inverse. This is actually really easy. When we do the inverse, we're just going to take our x and our y and literally flip where they are. So it said -2, -8. That becomes -8, -2. So 0, 2 becomes -2, 0. 3, 7 becomes 7, 3. And 4, 10 becomes 10, 4. Good buddy. I'm going to go ahead and graph this one in blue so we can see the difference. So we're going to do -8, -2, 0. I'm sorry, -2, 0. 7, 1, 2, 3. And 10, 1, 2, 3, 4. So you can see we end up with something that looks similar, but something a bit weird about it. Mr. Clark, what exactly is weird about it? Come, computer populated. So you have to wonder, what is weird about it? What is weird about it is this little curiosity. If I graph the line y equals x, I'm going to go ahead and do that real fast so you can see it. If I graph y equals x, notice how on a graph the line y equals x kind of makes like a mirror for the graph and its inverse. So that's kind of a cool little thing. It is true, and it does always work. So show the graph of y equals x, a dotted line on the coordinate plane. Oops, I made it solid. Well, whatever. Describe the symmetry among the three graphs. There is symmetry over the line y equals x. All right, easy enough. All right, number 7. Find the inverse of f of x equals x minus 4. This is going to be not too bad because I'm not going to check it. I'm just going to solve it. And I'll do that off to the side. So I'm going to step 1, y equals x minus 4. Step 2, flip-flop them, x minus y. X equals y minus 4. And then solve it for y. So x plus 4 equals y. Pretty easy. So I'm going to go ahead and do what it says next. Graph the function f of x equals x minus 4. Okay. And I will do that in this burgundy color. So that's going to be minus 4 and 1 over 1. Go ahead and graph my line, make it look nice. All right, step number 1, we're going to graph its, step number 2 is to graph its inverse. I'll graph the inverse in blue. The inverse was x plus 4. So we're going to do 4, and our slope is still 1 over 1. Go ahead and graph that. Oh, nice and straight. Okay. Well, straight-ish. Bear with me. It is on a tablet. And then we're going to do y equals x, and I'll do that in green. Y equals x. I do not like the way that blue line looks. Jeez, Mr. Clark, ever the perfectionist. Let's see here. Sorry, I just like to be precise. That looks a little bit better to me. Okay. So here we have our f of x, its inverse, and then y equals x. Describe any symmetry that we see. It looks to me like this is still symmetric over y equals x. All right, so your big takeaways for this section. Takeaway number 1 are going to be the steps to algebraically finding an inverse function. That's takeaway number 1. Takeaway number 2 is how to prove functions are inverses of each other by substituting f into its inverse or the inverse into f. And the third thing that I hope that you took away is that if you graph a function and its inverse, it is symmetric over the line y equals x.